in chapter 15, lesson 2, okay? It's talking about the wave properties. Again, the wave properties, guys. We have 3 vocabularies to learn. Amplitude, okay, wave length, and frequency. Again, we have 3 wave properties: amplitude, wavelength, and frequency. Okay? We said that amplitude is the distance between the rest position, this is the rest position, guys, this arrow, okay? And the highest point on the wave. So it's this distance. Okay? Are you still with me? Yeah. Guys, are you still with me?
Yes.
Yes. So we can say that amplitude is how high a wave can get. How high a wave can get. Okay? So again, the okay, so again, guys, amplitude is how high a wave can get. So it's the distance between the rest position, again, the rest position, let me use another color. Guys, this arrow I'm drawing is the rest position, okay? Are you with me?
Yeah, miss.
Yes. Yes. And the highest point on a wave, which is the crest in here. So this distance is called, what do we call this distance? Guys, this is a question. What do we call this distance again? The one from the rest position to the highest point on a wave. Yes?
The screen is freezed.
The screen freezed?
Yes.
You don't need the screen أصلا.
Okay.
I'm saying the distance between the rest position and the highest point on a wave. We just said, what's this? Yes, Word.
The amplitude.
Yes, thank you, Word. Thank you. Thank you so much. Yes, the amplitude. Guys, please try to focus. Even if the screen is frozen, try to listen, because we did this before. This is not the first time, okay? And please try to get your notebooks or take screenshots of whatever I'm writing and then write it in the notebook, because when you come to school, inshallah, I will see your notebooks. So be careful about this point. So again, chapter 15, lesson 2. We're gonna, inshallah, to finish it today, okay? It's talking about the wave properties. We have amplitude, wave length, and frequency. Amplitude, again, is how high a wave can get. But this is not the scientific definition we do need, okay? It's just like a definition to make it easy for you guys. But the scientific definition of amplitude is the distance from rest position to the highest point on a wave, okay? Or the distance from the lowest, from the rest position to the lowest point of a wave, okay? Which we call this point
Trough.
Trough, yes, that's right. Okay? Okay, so that's amplitude, guys. This is the amplitude. Do you have any questions?
No.
No. Yes. The wavelength afterwards, the wavelength is the distance from one point on a wave to the same point on the next wave. So if I draw another wave like this, and that's a longitudinal wave, okay? Should have another wave. Wait a second. Okay, so we have now two waves. As you can see, again, the wavelength is the distance from one point on a wave to the same one on the next wave. So if I said this point, this would be the next same point. The distance is called wavelength. Some people call it lambda, okay? It's called wavelength. Last year you learned that wavelength is the distance from crest to the next crest, right? Or from one trough to the next trough. And that's also right. But this year, inshallah, the definition changed into, again, it's the distance from one point on a wave to the same next point on the next wave. Okay? Yes, well, you raised your hand.
Miss, if there is only one wave, would there be a wavelength?
No, so the screen is still frozen. I drew two waves. Just give it time.
Yeah, I know, but if there only was one wave, would it have a wavelength?
If we have only one wave, you don't need
yes.
to learn the wavelength because you only have one wave.
Okay.
Okay? I thought the screen was frozen for you. That's why I told you to give it time. Okay, guys? Do you have any questions about this part?
No.
Are you sure about that?
Yes.
I hope so. Okay, now it's about the frequency. Okay? And let me do a part like this. So the frequency, as we learned about last year, is the number of vibrations per second. Okay? That's what we learned last year. But this year, it's not only the number of vibrations, it's how many wavelengths do we have in 1 second. Okay? So, for example, and by the way, frequency is how high or low a sound is, which we call pitch. Okay? It's how high or low a sound is. Low sounds, like deep sounds, like the sounds that are so deep, you know. Okay? High sounds are the sounds that, you know, like the siren of the ambulance, for example. This is a really high sound. السيرينة بتاعت الإسعاف. This is a really high sound. Okay?
Miss, I can't hear you.
Yes? Yes?
I can't hear you, Miss.
Maybe there is something with the internet connection. Guys, do you have the same problem?
No.
No, okay.
No, we don't. I can hear you.
Okay, thank you guys. So I think it's the problem with your internet connection, okay? Okay, so as we said, frequency is the number of wavelengths in 1 second. So for example, if I did a wave like this, and then another wave like this, this is one wave, and we have another wave. What do you think, which one will have higher frequency?
The
The first one?
The second one. Yes, that's a nice guess. That's a correct one too. The second one will have higher frequency. Okay? And that's because, as you can see in the next one, we have a lot of wavelength, right? Wavelength is the distance from one point to the next, right? So, can you see how many wavelengths do we have here? We have about 1, 2, 3, 4. 4 wavelengths, right? In the second wave, we have about 4 wavelengths, right?
Wavelength.
Yes. But look at the first one. We only have one wavelength. And frequency is or equals the number of wavelengths, which we call lambda. Okay? This is the wavelength, guys. Over time. So, when we have more wavelengths, that means, we have more frequency. That means that we'll have higher sounds. Higher sounds. Okay? Do you get this one?
Yes.
Do you
Yes.
have any questions about this part? Guys,
No.
physics is so fun, by the way, and it's really easy because you only need to understand. There are a lot of writing in the physics part here. You just need to understand what's going on, and then you can do well in it, okay? You just need to focus and understand. So, guys, please take a screenshot or start writing this down. And I will check the notebook, so make sure that you write these things down.
Miss, the people
Yes?
that will not go to school, how will you check their notebook?
I can't hear you.
The people that will not go to school, how will...
I will check it by camera. That would be a lot easier, right?
Okay.
Just guys, open your cameras. Let me see. Yes, you did the worksheet or the work I told you guys to do. And if you didn't, it will be. We'll have one online session. That means that I will be able to see those who are sitting in home. Okay? Guys, did you finish? Because I need to do something else for the wavelength. Did you finish?
Yes, Miss, we finished.
Yes, okay. So, this is the wavelength. If you looked at the wavelength again, this is the wavelength for the longitudinal or the transverse wave. Is this the wavelength for longitudinal wave or transverse wave? The one I'm drawing here.
Transverse.
Yes? Is it transverse wave or longitudinal wave?
Transverse.
Yes, this one. I can't hear you, by the way. This one, guys. This one with the arrow. What do you call this? Guys, is it longitudinal wave or transverse wave?
Longitudinal.
Transverse.
Longitudinal.
So one said longitudinal. What about the others?
Longitudinal.
Okay. Who are those who said longitudinal?
Yes.
Give me your names.
Karim.
Karim and
Muhammad.
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 Yes. Are you sure about this? Is this longitudinal wave?
It is transverse.
Yes, it's transverse wave. Guys, please. This is a transverse wave. The one with crest and trough. That's what we call transverse wave. This is chapter 15, lesson 1. That's why, guys, I told you to try to read whatever I give you because you don't have a book to study from. So I uploaded the lessons, but in PDF folders for you guys to read.
Miss, I thought
Just
that you were
read.
talking about one
Guys, to sit
in the top
down
right.
and study as hard as you could. I'm just asking you guys to read the lesson. After we finish one lesson, you start reading it.
Miss, I thought that you were talking about the one on the top right that have an arrow.
The top right?
Yes.
Yes, you mean this one.
Yes.
They are under frequency.
No, I thought you were talking about the one, the upper frequency. the two short
Even the
lines.
example I'm drawing for frequency is transverse wave. It's okay, guys. This is your choice. Okay, I gave you the choice to يعني have more easy or easier way to understand the lesson, because if you keep depending on only the explanation of the teacher, you will actually forget. That's why, guys, you need to work in home. And I give you the excuse, or I gave you the excuse that you do not have the book. So I uploaded the file. So please, next week, inshallah, when you guys come, when I ask a question about lesson 1 and 2, answer the question, because I'm not going to explain this again. Guys, this is not a trial. The online sessions that we're having now, it's not a trial. It's a real sessions. Okay? You will have quiz as soon as possible. After 3 weeks, you'll have your first term exam. So guys, please try to work hard. Do not depend that Miss Noha will upload study sheets or summaries before the exam, because no, I won't. I did this just because you guys don't have the book. But all you're gonna get are the worksheets to practice the lessons, but you're gonna study from the book or the notes you're writing after me. So these notes are just there to make it easy for you. Okay, grade 7? I'm not gonna repeat my words anymore, okay? You are grown up enough, and I hope you understand. So let me erase this wave. This is transverse wave, as we said. I just wanted to show you guys how do we measure the wavelength on longitudinal wave. So if I have longitudinal wave, we know that it's where some particles are closer to each other, others are far from each other. So we have here compressions and rarefactions. The part of the wave where the particles are far from each other is called rarefaction. Okay? The part of the wave where the particles are closer to each other, we call them
Compressions.
Compression.
okay? Yes. I want to measure the wavelength because sound waves move this way. Sound waves move in this shape, in longitudinal waves. Sound waves are longitudinal waves. But last time I told you, to make it easier, we sometimes draw the sound wave like a transverse wave, just to make it easy. If I wanted to measure the wavelength in here, I will use the same definition. It's the distance from one point on a wave to the same point on the next wave. So, for example, if I started from the middle of a rarefaction, it would go to the middle of the other one. So this is wavelength. Okay? Do you get this one?
Miss, the wavelength could be from any point in any wave to another wave, or it should be the wave after it.
It should be the wave right after it.
Okay.
Not any wave. The one that is next. For example, this is a rarefaction compression, okay? It will be the same point on the next compression على طول. Not another wave. It should be the next one. Okay? Like in crest and trough. It should be the next one على طول. It should be the next wavelength, or the next crest, the next trough, the next point. Okay? but should be the next same point. So I cannot say, for example, that wavelength is the distance from here to there. This is not a wavelength. Do you get it? Do you get this one?
Yes.
Yes. Let me erase it again. So again, if I said this is the wavelength, that's wrong. What if I said it's the distance from one compression to way far compression? That's totally wrong. It should be the same point on the next wave. Okay? Do you get this point, guys? Do you get this point?
Yes, yes.
Yes, okay. Let me share my screen again. So now you guys learned what are the properties of waves. The 3-1, amplitude, wavelength, frequency. You also learned how frequency and wavelength are related, because now you know that frequency is the number of wavelengths per time or per second. Okay? Do you have any questions about those two parts?
No.
Hope so. I hope so, inshallah. Okay, we have vocabulary that I told you guys to learn. We already talked about this a lot. Okay, we said more energy means more amplitude or higher amplitude. Okay, so when we increase the energy, we'll have higher amplitude. Okay? Okay, guys?
Okay.
Yes. The amplitude for the longitudinal wave depends on the distance between the particles. The distance between the particles in the compressions and rarefactions. The distance between particles in compressions and rarefactions. Okay? So when the distance increased between these two coils, for example, let me use a pen. Yes. Can you guys see these two coils?
Yes.
Yes.
I can see them.
The distance in here increased. It's not like the same one in the upper example, right? Is it the same distance?
No.
No.
It's not.
Yes, that's fine. Thank you, guys. Okay, let's move. You also learned about wavelengths, and we said wavelength is distance, right? Distance will be measured by meters. Okay, guys? We'll say 1 meter, 2 meters, centimeters, okay? But of course, it's measured more with meters. Frequency is how, or related to how rapidly objects produce sound or produce the wave itself. So when we vibrate more, or we have more vibrations, that means more wavelengths, which means more frequency. Okay? For example, if I'm hitting a drum, if I'm having a drum in front of me, and I'm hitting it, softly, this means low frequency. If I start hitting it so fast, that means I'm causing more vibrations to happen that will make higher frequency. Okay, guys? You will see more examples, inshallah, right now. Just let me move to the next slide. We're here having the definition of frequency, okay? And you also learned that the unit of frequency is hertz. Okay? So it's not measured by meter or centimeter or kilometers. It's measured by, its unit is called hertz. Okay, guys? Yes. And to calculate frequency, it means to divide the number of wavelengths by the time. Like this example we learned that we have here shorter wavelengths, but we have more wavelengths in here. We have 2 complete waves. But in the first example of the boy, we had only 1 complete wave. Okay? Okay, guys? Do you get this one?
Okay.
Yes.
Yes. So how does the wavelength change if the frequency of a wavelength decreases? In here, in this example, in the first example, we have less frequency, or lower frequency, if we can say. That means we'll have longer wavelengths. Longer wavelength means that the distance between one point to the same point on the next wave will increase. Okay, guys, do you get this one? How the frequency affects the wavelength. If we have lower frequency, that means we have less number of crests and troughs and so on, which means we have longer wavelength. Okay, as we said, today, inshallah, we'll learn about the wave speed. How the wave speed is affected by the type of particles. If it's solid, liquid, gas, the particles are a lot easier to vibrate than the others. If we still have material aslan for the wave to move through. So different types of waves travel at different speeds. Of course, the light wave is not the same speed as the sound wave. The light wave is way faster, by the way. Okay? The same type of waves travel at different speeds in different materials. Okay, so if I'm talking or we're having a sound wave right now, the speed of the sound wave will be totally different if it's moving through solid objects than if it's moving into water or if it's moving through air, because the particles of the material changed. In the solid objects, particles are closer to each other, as you know. And you already know this point. In the solid objects, the particles are way closer to each other. Not like in gas material. The particles are away from each other, like there is more distance. Let me show to you guys. And you do understand this point. But let me. Guys, I'm gonna clear the whiteboard. Okay? Do you still need me to leave it for a few seconds?
No.
Clear all. So we have three states of matter. We have solid, liquid, and gas, right? The particles of solid objects are really close to each other. Imagine these circles, the particles of the solid objects, like a wall, whatever, okay? Can you see how they are close? In the liquid, we have more distance between the particles. That's why it's liquid. It takes the shape of the matter, of the container it is in. But then we have gas, where particles are way far from each other. And that's why gases do have mass, but they do not have any shape. They take the shape of any container. Okay? Okay, guys? Can you see the difference between the particles?
Yes.
Yes. If a sound wave, this is a speaker, for example, and someone's talking, making sounds, which is longitudinal wave, or we can say mechanical wave. The waves will move through the particles and then will cause the particles to vibrate. So each particle will move the energy to the next one. Each particle will move the energy to the next particle, right? It will move this way, for example, into the next one, into the next one, and so on. Here, the sound will move faster because the particles are closer to each other. But look in here, in the liquids, if we still have a speaker, someone is making noise, someone's talking, okay, making a lot of noise and energy, the energy will also move through particles, but it will have more distance, as you can see. It will have more distance to travel through. Can you see? Guys, do you get this one?
Yes.
Yes. So here we have less speed. It's not the same speed. Still, solids are faster. In the gas, we'll have the same speaker. Okay. What's going on? Give me a second, guys. Okay. Again, we're having the speaker in here. People are talking. We're having sound waves moving. Can you see the distance the waves will cut to reach each particle? This is longer one. So this one is slower, where waves move slower, not that fast. Do you get it now? Do you get, guys, what I was talking about?
Yes.
That wave speed differs, or it's different from one, type of state or type of matter to the next. It's not the same wavelength. Okay? You still have any questions about this part? So it depends on the particle of the matter itself. If the distance between the particles are close to each other, that means the waves will move faster because waves are closer. They will not cut more distance. But in liquid and gas, you can see that it's getting slower. Okay? Okay?
Okay.
Guys, I do hope you understand. Are you not, and you're not saying okay just like that, so we can end the session. I hope so. Temperature also will affect the speed, because when the temperature increases, the particles of a matter will move way faster. That means that they will get closer. Okay? Okay. As you can see here, for example, the wave speed increases in the solids. As you can see, the wavelength increased in solids. We have solids, ice, and aluminum. We can see that the wave speed increased, not like in gas. So what does wave speed depend on? It depends on, why is it moving this way? So it depends on the type of the type of the wave itself. Is it light wave? Is it light wave? Is it sound wave? Is it electromagnetic generally or mechanical energy? That will make different speeds. Okay. The type of material the speed is the wave is moving through, and temperature. So we have three things that affect the wave speed. Again, we have three things that affect the wave speed. What is the type of the wave in the beginning? Is it electromagnetic, mechanical, whether it's sound, whether it's light, as we said? The type of material is moving through solid objects. Is it moving through liquid or gas? And the last thing is temperature. Okay, because temperature, of course, will affect the speed, because when we have higher temperature, that means the particles will move way faster because they will have more energy. Okay, okay, how to calculate the wave speed? How do I know? How do I know the wave speed equation? It's way easy, guys. If you understand it, it will be easy for you to remember it. So we can calculate the wave speed by multiplying its wavelength and its frequency. So now we'll have a multiply. Okay? So guys, you have two equations that you learned. Let me share the whiteboard again. You have two equations. You have two equations. You have the equation for frequency. You learned that it's wave length. We can say the number of wavelengths over time. And you have the wave speed equation, and it says it's the wave length multiply. I will continue, okay, because you will have less than 5 minutes. So as we said, you have two equations you learned this year. The one for frequency, which says it's the number of wavelengths over the time. And you learned another equation, which is wave speed. It equals frequency or wavelength multiply the wave length. Okay, as I told you guys, the wavelength will have another symbol which will make it easy for you to write it. It's called lambda. Okay, over time, that's easy. You don't need to for this to make it easier. The frequency is with F. Okay, the speed, the wave speed, we can say S. So it equals frequency multiply lambda. But if we're using symbols like that, we don't put X between them. Okay? Or the multiply symbol between them. Because here it will be considered an X, like an unknown thing. So we do not do this. We write it like this. Let me show you. It will be like this. So this dot in between resembles the multiply thing. Okay? Okay. The frequency, guys, the frequency is by hertz. Okay? Multiply the lambda will be measured by meters. I'm just saying the units, guys. These are the units. Okay? Here, lambda is, if I did it here again, over time. That means meters, right? Over seconds. Meter over seconds. That equals hertz. This is the unit we're using, guys. Yeah, if I said the frequency will be 4, we say 4 hertz. If I say wave speed is hertz multiply meters, that will be also something used in math, because hertz itself equals meters by seconds, which is time. And here we'll put multiply the m only for the wavelength. Of course, m multiply m will be double m bare second. So this is the unit for speed. I'm not going to ask you for all these explanations. It's just for you guys to make it way easier for you to understand where did we get the units from. Okay? Okay, I hope you guys understand. Inshallah, I will try to upload the sessions as soon as I could before next week. So when you guys come, you will be as ready as possible. And next week, inshallah, we will do a worksheet. So I'm giving you guys time to read. Please read the PDF files I uploaded for you guys so you can remember what we are talking about. Do you guys still have questions before leaving?
No.
Yes.
Miss, is there a homework?
Will be a homework? No, you will not have a homework. We'll do it next week together. We'll do the worksheet next week. Okay? Okay?
Okay, Miss.
Okay.
So next week, inshallah, we will do some equations. We'll solve some wave speed problems, and we'll do a small worksheet in the next session, inshallah. Okay? Okay, guys?
Okay, Miss.
Okay, see you next time. Bye.